Hey there, science fans. Welcome to another exciting episode where we unravel the mysteries of the digital world. Today, we're diving into the awesome world of computer networks. These networks are the backbone of our modern digital lives. Imagine a network as a giant web connecting computers all over the globe. This web allows us to communicate, share, and access information instantly. It's how we share information, watch funny cat videos, and stay connected with friends and family. Pretty cool, right? Whether it's a video call with loved ones or streaming your favorite show, networks make it all possible. But have you ever wondered how this information travels seamlessly from one computer to another? It's a fascinating process that happens in the blink of an eye. It's like magic, but instead of spells, we have something called the OSI model. This model breaks down the complex process into manageable layers. Think of the internet as a giant postal system. Just like how mail is sorted and delivered, data is processed and sent across networks. Your message is the package. It gets wrapped up, labeled, and sent on its way through various checkpoints. And the OSI model is like the set of rules that ensures your package reaches the right destination. Each layer has a specific role, ensuring smooth and accurate delivery. Intrigued? Let's explore this fascinating world together and uncover the secrets behind the networks that power our digital age. Now, networks can be pretty complex with tons of different devices and protocols involved. That's where the OSI model comes in. OSI stands for Open Systems Interconnection. It's like a blueprint that breaks down network communication into 7 distinct layers. Why 7 layers, you ask? Well, just like a delicious layer cake, each layer in the OSI model has its own specific function. This makes it easier to understand, design, and troubleshoot networks. Without the OSI model, it would be like trying to bake a cake by just throwing all the ingredients together at once, a recipe for disaster. Ready to dive deeper? Let's explore each layer of the OSI model one by one. Remember, we're going from the bottom up, just like building a cake. This is the foundation of our network cake. The physical layer deals with the physical transmission of data over the network. Think cables, connectors, wireless signals, all the hardware stuff. It's responsible for converting bits, the ones and zeros that computers use, into electrical or optical signals that can travel over the network. Imagine it as the delivery truck transporting your package. Moving up, we have the data link layer. This layer is responsible for error-free transmission of data frames between 2 nodes over the physical layer. It uses MAC addresses to identify devices on a network, kind of like a home address for your computer. The data link layer also ensures that data is delivered reliably, without any errors. Think of it as the postal worker, making sure your package is in good condition before delivering it. Next up is the network layer, the traffic cop of our network. This layer is responsible for routing data packets across networks. It uses IP addresses, which are like zip codes for computers, to determine the best path for data to travel. Just like a GPS helps you navigate, the network layer ensures that your data takes the most efficient route to its destination. The transport layer is all about reliable data transmission. It ensures that data is delivered in the right order and without any loss or duplication. Think of it as the guaranteed delivery service for your package. It also handles flow control, making sure that the sender doesn't overwhelm the receiver with too much data. This layer is like a careful packer, making sure your package arrives complete and undamaged. Session layer, managing conversations between computers. The session layer establishes, manages, and terminates communication sessions between applications. Think of it as setting up a phone call between 2 computers. It synchronizes the conversation, making sure that both sides are talking and listening at the right time. This layer also handles authentication and authorization, making sure that only authorized users can access the network. Presentation layer. Making data understandable. The presentation layer is all about making sure that data is presented in a format that both the sending and receiving applications can understand. It handles tasks like data encryption, compression, and conversion between different data formats. This layer is like a translator, ensuring that two computers speaking different languages can still understand each other. Finally, we reach the top layer, the application layer. This is the layer that we interact with directly. It's where our favorite applications like web browsers, email clients, and video streaming services reside. This layer provides services to the user, allowing us to access and share information over the network. It's like the front desk of our network building, where we go to request information and services. Still not clear on how these layers work together? Don't worry, it's a common feeling when first diving into the complexities of network communication. Let's look at a real-world example to make things clearer and more relatable. Imagine you're sending an email to your friend. This simple action involves multiple layers working seamlessly together. 1. Application layer. You compose your email using an email client like Gmail. This is where you write your message, add attachments, and hit send. 2. Presentation layer. The email client formats your email into a standardized format that can be understood by other email clients. This ensures that your friend sees the email exactly as you intended. 3. Session layer. A session is established between your computer and the email server. This session keeps the communication open and manages the data exchange. 4. Transport layer. The email is divided into packets and assigned sequence numbers for reliable delivery. This layer ensures that all packets arrive correctly and in order. 5. Network layer. Your router uses the IP address to determine the best route for the email to reach your friend's computer. It finds the most efficient path through the network. 6. Data link layer. Your computer's network card adds MAC address information to the packets. This helps in identifying the devices involved in the communication. 7. Physical layer. The email is converted into electrical signals and sent over the network cables. This is the actual transmission of data through physical media. The same process happens in reverse on your friend's computer, allowing them to receive and read your email. Each layer plays a crucial role in ensuring the email is delivered accurately and efficiently. Pretty cool, right? So why is the OSI model so important? Well, for starters, it provides a common language for network professionals to communicate and collaborate. It also makes it easy to develop, implement, and troubleshoot network technologies. By breaking down complex network communication into manageable layers, the OSI model simplifies network design and management. This ensures interoperability between different network devices and protocols, allowing for seamless communication across the globe. The OSI model is also an invaluable tool for troubleshooting network problems. It breaks down the complex process of networking into 7 distinct layers, each with its own specific function. This layered approach allows network professionals to pinpoint exactly where an issue might be occurring, whether it's at the physical layer where hardware issues might arise, or at the application layer, where software problems could be the culprit. By understanding the function of each layer, network administrators can quickly isolate and resolve issues. For instance, if there's a problem with data transmission, they can check the data link layer for errors in data frames or the network layer for routing issues. For example, if a user is unable to access a website, the administrator can use the OSI model to determine if the problem lies with the physical connection, such as a broken cable or faulty hardware, the IP address configuration, which falls under the network layer, or the application itself, which is at the topmost layer. This methodical approach ensures that no stone is left unturned in the troubleshooting process. Moreover, the OSI model provides a framework for designing efficient and scalable networks. It helps network designers to plan and implement networks that are not only robust, but also flexible enough to adapt to future needs. By carefully considering the requirements of each layer, network designers can build robust and reliable networks that can handle the ever-growing demands of modern communication. This ensures that the network can support a wide range of applications and services, from simple email to complex cloud-based solutions, making the OSI model an essential tool in the world of networking.